Today let's go over a sequel to a Grind 75 question. My last video was search a 2D matrix, so naturally let's follow up with the second version of the question. The idea here is the same. You want to write an efficient algorithm that searches for a target value, an integer, inside of this matrix if it exists. And if it does, return true. If you go through every single element however you want, whether it's rows or columns, and you've never find the target integer, then return false. Right, and again, you're given some information here that the rows are sorted in ascending order, and also the columns are sorted in ascending order. So what this means is that you can do binary search either row by row or column by column. I find it's easier to just go through all the rows because getting the columns can be a little tricky, and it just takes more time. So yeah, this is very similar to the previous question, almost identical, so let's solve it. Again, I'm going to show you the naive way, which is just iterating over every row from left to right. So every single row. And then just asking if, okay, why is this not working? Okay, sometimes a browser doesn't refresh until I refresh it. Anyways, my tab key was not working, return key. Anyways, like I was saying, we're going to go through every row from left to right, and if the target is in the current row, return true. And if we went through every single row and we never find the target value, return false, right? After you go through every single row, target is not in any of these rows, then we can return false. And as you can see, it works, but there's a better way to do this. As before, binary search on every single row, right? So you already know that every row is sorted in ascending order. So what that means is, like, for example, if we have 1, 4, 7, 11, 15, we're going to start here, and we're going to ask if we find target in here by cutting the array in half over and over again and moving the pointers based on how close we are to finding the target. And this is how we define a binary search, because in the worst case, the value could be the last one, which would make the binary search O of n, but in most cases it's not. Let's cut the array in half with a midpoint, and let's ask if m of mid is equal to target. If it is, cool, we got lucky, we found the target right away. If it's not, if it's too big, we close the right half, right? If we're looking for 2 and we see 7, we can close the right half because we know that it's not going to be in any of these because this is already too big, right? If it's not true, we do the opposite with left. So by the end of this, right and left will meet, and that will be your value. And then at the end, right, we still have to go through every single row, so that's O of n, but after every row, at least this part is log of n now, we can return false if we never find the value through all of our binary searches for each row from left to right. And as you can see, it works, and this is a much better way to do it that reduces the time complexity. So I hope this made sense and it's intuitive. Thank you for watching, and stay tuned for more, and hit that subscribe button if you guys like what you're seeing.